We're beginning our chapter on area and perimeter. We're going to be looking at multiple shapes and really start relying on knowing a lot of formulas. Now, I do give you a formula sheet, so you don't need to memorize them, but the formula sheet does not say what shapes they go to, so you will need to know what formula to use on each shape. We're going to start with review in this section. We're going to be looking at triangles and parallelograms. We've already learned these formulas. So we're going to start with something we know, and then we'll build off of that. Now, starting from here until the end of the year, we're going to be seeing 3 lines of work on nearly every problem we do. This is going to carry on into chapter 12, which is our last chapter. So I'm going to need to see 3 lines of work, and I'll explain that and review that as we go along here. First of all, perimeter does not have a formula. Okay, you're just simply going to add up all of the sides on the shape. Area does have a formula. Okay, some people think of it as length times width, and others call it base times height. Okay, we're going to use the base times height version of it. We're going to abbreviate it as B times H though. Okay, so for parallelograms, this also works for squares and rectangles because they are also parallelograms. We learned that in chapter 8. We're looking at this for our formula. Okay, now when you use the base and the height, notice the symbol that's in between the two on the picture over on the right. Okay, the base and the height are always perpendicular. Okay, you have to look for that right angle symbol. So let's look at these two right here. Okay, so on the left, here's where we're going to practice the 3 lines of work. Okay, first is to write your formula. Area equals base times height in this case. Okay, that's always your first step. Always. You cannot get an A on a test if you aren't showing your work. Okay, I have to see what's going on inside of your brain. Next step is to put in the numbers you know. And the last step is the answer. Okay, so the numbers we know are the base and the height on this one, giving us an answer of 42. And if it's area, your units are squared. So I'm always going to be looking for those 3 lines of work, no excuses. All right, this next problem is a working backwards problem. You still need to start by writing the formula. This shape is area equals base times height. We're going to put in what we know, same next step. On this one, we happen to know A, so we have to put that in for A, the area. We also know the base, and then the height is X. Okay, divide both sides by 10, and we get our answer. Okay, now why isn't this answer right here squared? Okay, because it's not the area. Okay, it's the length of how tall that parallelogram is. Okay, so we do need units if they give you units on the problem. 3 lines of work, always, minimum. You can show more if you want to. Okay. All right, we're going to do another parallelogram problem right here. So they've given us multiple numbers and a variable. We're supposed to solve for x. Okay, here's what we know. We know this is a parallelogram, so we know we should start by writing the formula for parallelograms. And then we're going to put in what we know. We currently don't know the area, but we want to find the area. Okay, because it's going to help us find x. Now we have to pick a base and a height that are what? Perpendicular. Okay, so we have to look for 2 numbers that form a right angle with one another. Well, looking right here, this 9 and 15 are perpendicular to each other. So we're going to pick that, 9 and 15. Okay, we're going to get the area. There's no units on our picture, so we don't need units on our answer. But now we know that the area of this parallelogram is 135 units squared. Well, we know the formula for this parallelogram to find the area is A equals BH. Now that we know A, we can put that in right here. And then we have another set of base with height that are perpendicular to each other. Okay, so that's going to be the base and the height that we use here. We divide both sides by 18, and we get our answer for x. So we're going to move on from parallelograms and talk about triangles for a little bit. So the other formula we're reviewing today, not learning, because we've already talked about these throughout the year. Area of a triangle is 1/2 BH, 1/2 base times height. Notice here that the height and the base are also perpendicular. Okay, so you need to look for that right angle symbol. They're going to possibly give you more information than you need. You have to pick the right two numbers for the base and the height. So we're going to try these. Okay, both of these have more information than we need. We just have to make sure we pick the right numbers. So we always start by writing the formula. 1/2 base times height. And we're going to put in what we know. Remember, the base and the height are always perpendicular to each other. So you're looking for that square to show you that there's a 90-degree angle. Okay, so the base and the height on this one would be 9 and 4. If we multiply all of that together, we get our area with inches squared for the units. Okay, on the next one, we've got 1/2 base times height because it's a triangle. We put the numbers in that we know, which are the base and the height. Okay, again, we're looking for this square right here. So we know we're going to pick 3 and 4.2. We multiply all of these together. And get 6.3. So again, on all of your homework problems, I'm going to be walking around. I'm going to be making sure that you have 3 lines of work on every problem. Okay, let's try a solving backwards problem with these triangles. All right, always start with the formula. We know the area on this one? Yes, we do. So we've got 30.55, 1/2 base and height. Okay, now they gave us more information than we need. Again, we're always looking for this right here. So what two sides are perpendicular to each other? 6.5 and x. Okay, so on this one, to simplify the right-hand side, we're just going to multiply the 6.5 times 1/2. We still have our x there. And then we can divide both sides by 3.25. So we found the height of the triangle. Okay, the height doesn't have to be always inside the triangle. Okay, it's just how tall it is compared to the perpendicular base. Okay, we've got one example left, which is a two-step problem. Okay, it looks more difficult than it is. So we've talked about parallelograms, base times height, triangles, 1/2 base times height. We're going to use both of those on the next problem. Okay, so here we have this shape. It's an odd shape. Okay, we want to find the shaded region, the yellow one. Okay, so right now it looks like we may have to break it up into a few pieces and add them together, but it's actually easier if we use subtraction. So think about this shape and how we could utilize subtraction to help us. Maybe we could find the area of the square and subtract away the triangle that got taken out. And whatever's left over is the yellow region. Okay, so let's talk about the square first. Formula for any square rectangle parallelogram is base times height. So we write our formula first. The base and the height are 8 and 8. So the area of the whole thing, if that triangle wasn't taken out, would be 64. Well, let's think about this triangle up here at the top. How long is the base right here? Okay, well, we know that's 8 because of this blue dash. All the sides are the same. And how tall is it? How tall is the height that I drew in right there? Well, this helps us right here because from here to here is 5, which means the other part that we drew in the triangle, is 3. So the area of the triangle is going to be 1/2 base times height, the base being 8, the height 3, which means we have 12. So the area of that white triangle that got taken out of the shape is 12. So the yellow region would be 64 minus that triangle, or 52. So there are going to be situations on the homework where it may be beneficial to add shapes together. For instance, if you had a shape like this, okay, where you have a rectangle and a triangle, that would be beneficial where you would find the area of each of these and add them together. This situation that we went through before, this yellow one, is a situation where subtracting is easier than adding up. So keep an eye out for that.